Hello guys, welcome to another Alias modeling tutorial. In this one we'll be building the bolt nut cap. It looks simple, but it requires specific knowledge to make it right. This time we'll be using new version of Alias 2024.0 or beyond because of the new tool, feature modifier, that is crucial for merging Audi logo to the curved surface of the cap. If you don't have it, you can download educational version from the official Autodesk website. It's completely free and feature complete except of the export options. As always, content for the beginners, but not for the first timers. Let's jump in. Okay guys, so we are in Alias. As you can see, this is the brand new Alias 2024.1 Learning Edition. Now, one of the cool features of this new version, well, a part of the brand new interface, which is much better than it was, is the new feature that I actually introduced, or one of them. So this feature is crucial for this lesson. It's called feature modifier, and we will use it at the end. So when we make all of the basic stuff, all the main stuff, and then when we combine everything together, we'll be using this stuff. So if you really want to follow along till the very end, I advise you to go to the official website, Autodesk, and just grab your own learning edition. It's absolutely free, $0. The only limitation of this version is you can't export anything, well, except the wire files. So there is no export options. But apart of that, everything else is here. So it's in terms of the features, it's the same as the kind of full version, the combat version. All right, so these are out of the way. As always, let's go to the construction options. I already opened them for you. Now, once again, if you want to follow, use the same tolerances. It's important. As you can see, they are pretty tight. And on top of it, the rational flags. Now, the rational flags are extremely crucial for this model, as for the previous as well. But I never actually described what these rational flags do, except of like they do curves perfect, right? But this is a very vague description, isn't it? So I guess I owe you explanation on this one because we will be working with circles a lot. Audi logotype, they're just rings, perfect circles intersected with each other. So what is rational flags? Why are they not turned on by default? Well, there is a couple of reasons to that. So as you know, probably already know, Alias has two types of circles, or two tools to create circles. One of them in your original palette here. Here is the circle, and another one in the Key Point Curve Toolbox. This one. So the only difference between them is the one doesn't have the additional attributes, and the other one does. So the Key Point Curve Toolbox, this one, has additional attributes which you can change, and these attributes are the radius or arc length, which is really important because sometimes you need to be, spot on, very specific, and you want to build the circles with a specific radius. Well, that's why when you use this stuff. Now, in all other aspects, they're equal, identical, if you will, and both of them are working with the rational flags. Now, when the rational flags turned on, all of the circles, it doesn't matter which one you choose, automatically will produce you the circles. It's called non-periodic circles. So basically, instead of creating a curve which bites its tail, it creates a few segments and then stack them together. So when you click on rational flags, it always be segmented circles. There is no other options, and it's actually really beneficial in general. It's a good rule of thumb to use segments on non-periodic circles. But this is not the only thing which rational flag does. One important thing to understand is the rational geometries in general is a ratio of sums of polynomials in comparison to just a sum of polynomials when you're working with non-rational geometry. As a result, it's pretty complex, but it gives you mathematically, but it gives you a perfect curves. And when I'm talking about the perfect curves, I'm talking specifically about the circles. All these rational flags is about circles and rational geometry, which you can build from the circles, so the surfaces, if you will. Now, if I'll go and I'll create the circle, it doesn't matter which one. Let's take this one. Now, let me just go here and see. So let me create a circle, just a demonstration, 4 segments, 3 degrees, 1 span. Now I'll create the circle, as you can see. Actually, no, let's do different stuff. I'll do original one, so this size always will be the same. So the same stuff. This is just a regular circle under the rational flags, 4 segments, 4 segments. Now I will uncheck the rational flags and build it once again. So let me double click. So 4 segments, 3 degrees, same stuff. Click again. Now, if I'll use the, if I'll check the radius, you will see that the rational flagged spot on and the non-rational flagged, you know, just wobbling around, even though the structure is equal. So how it happened and why? Well, once again, this one under the rational flags, which means it has a different math, and on top of it, what it does, what it brings, visually, is the different weight for the CVs. Now, in the non-rational geometry, if you pick any CV in the information window, which is in Windows information window, this one, you will see that every CV has weight parameter. So how much it contributes to the curve it sits on. So as you can see, everything here is 1, even the endpoints. Everything is 1. Now, if I will select these ones, you will see that the weights are different. This one is 0.8 something, and this one is 1 probably, and this one is 0.80 something again. So the rational flags brings different weights to the circles, to the CVs on the curves, which forms the circles, to maintain its perfect accuracy. So the contribution of every CV point is different. That's why it's perfect in comparison to this one. For this one, you need to bring more and more and more and more CVs and more segments to make it work. Now, and technically, it's still not be absolutely infinitely accurate. Now, why these rational flags are not turned on? Well, there is a few reasons for that. Well, first of all, as I mentioned, this is a ratio of sum of polynomials, which means it's pretty taxing on, in terms of math. So if you have a slow machine and you have a bunch of this stuff, it will slow your progress. Everything will be really slow and, unresponsive. So a lot of calculations. But this is not the main reason. I believe the main reason here is because of a downstream CAD software. So when you build the models in Alias, you build mostly on the shells. So the A side, the consumer side, and the B side, the engineering side, designed in other CAD software, like the generalized CAD systems, like, Fusion 360 or maybe, SolidWorks, whatever. And not all of them really understands rational flags, and not all of them really understands the different weights of the CVs. And as a result, they will butcher your geometry. And I think last but not least is it's pretty destructive. So when you build this geometry, the rational geometry, there is a lot of chances there will be a lot of multi-nodes inside, and multi-nodes and a lot of our endpoints stuck together. Now, which means that when you will try to change this geometry by manually moving CVs around, 99% of the time you will destroy your geometry. You will destroy the normal mass will be off, the actual geometry will be off, and there is no way to fix it. So it's kind of destructive. You build it, the only thing you can do is to align it with the same rational geometry. You can't really manually tweak it at that point. So this is like the few reasons why the rational flags are not turned on by default. Now, as we're working with the circles, and we'll be working with the circles a lot in this lesson, these rational flags are extremely important. Now, let me delete this stuff and actually start modeling, because I guess I already take a lot of your time. So let's go to laying down first curves, and I need to place a circle. Now, so I'll be using these circles because I need to define a specific radius. Now, so click on this one, hold Alt, click, and click somewhere else. It doesn't matter where. Now I have my circle. Now, if you select it as a object, you will see that there is no parameter for no additional attributes, like radius, arc length, which I mentioned before, like where they are. Well, as this is a rational flagged circle, it consists from a few segments. What Alias did is it grouped them together. And of course, for the group, you don't have these attributes. So if I'll pick the curve itself, yeah, here is the attribute now. You see arc. And now I can change the radius and change it really precisely. That's exactly what I'm gonna do. Now, first of all, I will delete all of this stuff and probably ungroup it. So ungroup is Control U. I guess it is a default hotkey for ungrouping, and grouping is Control G. So what I'm gonna do is I'll select it and change the radius to 3. I'll hit OK. Now, this is the outer edge of the circle, which I'll be working with. As you can see, it's very tiny. We will be working a very tiny scale, and it actually brings a lot of complexity and different oddities into the model. So, well, you will see it. I'll see it later, and I'll show you how to battle it. Now, so I have this object, this segment. Now I will duplicate it, just Control C, Control V, and change the attribute to 2.48, like this. Now I will select it, duplicate it again, and change it again to 2.23, like this. All right, so now we have our curves, and what I'm gonna do is I can just use the mirror options, or mirror tool, sorry, to just mirror it across the global axis like this. All right, what I'm gonna do next? Now we are building the first ring for the Audi logo, and we'll be building it flat. So what I'm gonna do now is I will take all of this, group it, select it as a group, and push it up, hit tab by 0.75. Push it up. Okay. So these rings, they have a profile. So if you look at from the side view, let me just change the perspective. So there should be a specific profile like this and this. And as you can see, it's not kind of symmetrical. So the center is biased towards the inner radius. Now, how are we gonna create it? Now, you probably say that, you know, you're just gonna create a curve, you know, bring more degrees, and from the side view, just move it somewhere, right? Well, like this, right? Well, the truth is that this is the wrong approach. Now, the actual Audi logo designed with circles, and this curve is very specific. So basically, in the actual logo type, what they did is they fit another circle here, which will touch these endpoints. So endpoint here and endpoint here. Now, how you can do it in Alias? Now, of course, you can just, you know, lay it down and do some math and calculate the radiuses and figure out what it is. Or you can use a feature not a lot of newcomers actually using. It's called arc. Now, in the key point curve toolbox, or here you can click, there is an arc tab. And you can see there is a few options here. So what we're going to use is we'll use the arc free point. Now I double click on it and I will change my degree to 3. Hit OK. Now I'm using 3 degrees because this is a, you know, a minimum requirement to really create an accurate surface. Remember, it is in the rational flags, and the arcs are the parts of the circles, so they behave with the rational flags turned on. Now what I'm going to do is I will Control-Alt-Click to snap. This is the 1 point, repeat on this one, and the third one will be on the other side. So let's just do that. Here we go. All right, pretty cool. So as you can see, this is almost a circle, and as you can see, it touches both points here, which is exactly what I want. Now, if I'll check its continuity on basically the curvature comp, you will see that it has a constant acceleration, and it's supposed to, because this is a part of a circle. If I'll click on the radius, as you can see, it's constant. Now, what I need to do next is I need to cut it. Now, there is a couple ways how I can do it. Now, one way is use a fit curve. Now, fit curve doesn't behave with the rational flags turned on, but we still can use it because the actual you know, curve is really small and probably won't have any deviations here, and it actually doesn't. But if you really want to be spot on, what I suggest you to do is just detach it. So I'll use detach tool, snap it, and detach. hitting spacebar. Now, as you can see, there is two separate curves, but both of them, now let me just pick the radius here, check it. You see, it's absolutely identical. And it has the same structure, so 3 degrees, 3 degrees. Now, when I'm saying 3 degrees, it means that there is actually much more because this is a span surface, right? So, but it still creates the 3 degree before it creates a span. Now, these are the way. Now I can delete it. I don't need that anymore. And I need to do another one on this side, on the inner side. So to do that, I will duplicate this circle, move it away. And now, by the way, I mentioned it before, but if you don't have the gizmo, well, that's because by default Alias hides its gizmos. I don't know why. It's actually a very convenient way of modeling, especially in Alias. And if you really want them, and they are in the transform section, here they are. And you just can hook it to your hotkeys and just work the same way. Now, so what I'm going to do, I will select it, set up the pivot using set pivot tool, and snap it here like that. All right. So now let me use the same arc once again, 3 degrees, single span. I will click. Actually, I'll start from this part. Oops. So snap, snap, and snap. Okay. And now we have another one. As you can see, perfect. Now I will use detach tool again and detach it using snapping, like this. All right, now I can delete it. And as you can see, we have two curves for profile. This is the one, this is the second one. And they're perfect. They're exactly the way how they build in reality. Now, what are you going to do next? So probably what you're thinking about is like, oh, okay, I can just, group this stuff, to center the pivot along the global origin, and I will just rotate it to create a segment, and then I'll create a, square or, like a rail. So let's try to do that. So first of all, what I'm going to do is I'll click on the object like this, duplicate object controls. I will say 4 on 90 degrees and hit build. So now I have them on all sides. And now what I can do, now let me go actually work from the x-axis looking in this direction. It's kind of a little bit more familiar for me. So what I'm going to do now is I will create a square. So I'll use a square tool, right? I will use continuity like a G0 and just build a square here like this. Oh, you may say, well, that's nice. This is exactly what we want. Let's do everything like that. But in reality, it is not. Now, if I will isolate this stuff and bring some isopalms on the surface like this, and then I will check the radius. Let's see. Okay, this one perfect. Let's see this one. This one perfect. Well, no problems, right? But if you're starting to click somewhere inside of the surface on these isopalms, you will see that it actually wobbling around, you see? Now, it's almost perfect, but it's not perfect. Now, I'm looking for the perfect circles and the perfect surfaces from the circle, so this one will not do for me. Now, the reason why square doesn't really work is because it has the linear blend between the edges. So, as you can see here, 1, 3, and 2, 4. So this to this and this to this. And it's designed specifically to create patches between the different surfaces, right, and the different parameters of continuity. So that's why it doesn't really work here. Now, let me delete it. What other options we have? Now, you probably say, well, the rail tool, right? The rail tool is good here. We have a generation, we have a rail. We have even 2 generation curves and 2 rails. Well, not use this one. Well, let's try again. So generation, rail. Oh, sorry, 2 generation, 2 rails. 1, 2, 3, and 4. And as you can see, we don't even have it. So it doesn't really want to build. The only way to build it is actually rebuild the curves, my perfect curve. So what it does, it rebuild my perfect curves because it don't really understand the rational flags, and it just doesn't really want to build it the way I want it to. So the surface is even worse. So it just has spans now, all of this stuff. So it's definitely not accurate. Now, will not work. So let me delete it. Okay, what other options we have? Now, skin, right? So we can use, I won't be showing you the skin, but yeah, you have this option for the crown mode, but it's not exact as what I built. So yeah, good luck with that. And on top of it, it doesn't really care about your rational flags as well. So what other options do we have? Well, if you said that, oh, maybe it is a revolve tool, then you will be correct. One of the tools we can use is actually the revolve tool. So if I'll open up revolve, right, 4 segments, 3 degrees, the same way as I build everything else. Now I will click on this one, and voila. Now let me isolate this stuff. And actually, let me just delete this. I don't need that. And use my isopams again and check it. You will see that now it's not wobbling anymore. It's perfect. Now the revolve command actually behaves with rational flags really well because what it does, it revolves around the circle, right? So it's not a surprise. Okay, are there any other options which I can use except of the revolve? Well, yes. Actually, I will use another tool instead of a revolve because for this specific model and this type of product, another tool is more beneficial, and I will figure out why later. So this one called the profile tool. This one, profile. I believe it's somewhere in the just surface. If I'll click on the rail, yeah, here it is, the profile tool from the original palette. So if I'll click on the profile tool and I change the profile orientation to neutral and the frame travel to radial, I can click on Bezier if I want. So I'll click on this one, click accept and click done. I'm hitting spacebar and then click again and spacebar again. Well, yeah, look at this, I have the same stuff. Now I can obviously, why is this stuff? Oh, sorry, I think I just didn't really delete the original surface. Oh no, I did. Sorry, let me try again. Okay, right now it works. So once again, I won't be checking it. Trust me, it is the same as the revolve. It's perfectly accurate and it works. So the profile tool is the tool a lot of newcomers really just overlook. The reason for that is because it doesn't do what people think it's supposed to do. It actually, what it does a profile. So we'll take a profile and honestly push it around the path. It doesn't even try to bend the profile itself. There is no interpolation between the 4 edges or 2 edges, depends on what kind of options you use in terms of the rail tool. So it's very honest. It used a lot in automotive industry to create railings and stuff, and actually in a lot of other things as well. For us, it's a perfect tool to work with for this project. So I will be using the profile tool. So let me just delete it, push it back, and kind of like try it again. But this time, what I'm gonna do is I will create the profile, but without the chain select option. So here I will uncheck it, click, accept, done, click again, and build. And I will do the same for this side, accept, done, click, and build. Now I'm hitting spacebar to go through the stages. Now, okay, looks pretty cool. What else could I do? Now, at this point, I actually don't need all these curves. They're kind of like standing in a way. So what I'm gonna do is I will select all the curves like this, right? And just delete them. And I left only with the curves. Now, obviously I can just flip it a couple times and get my main surfaces for the ring, for the first ring. But as you can see, we are missing crucial component here. It is the transition between these two surfaces. So let's do that. So what I'm gonna do is I will, I'll probably delete all of this stuff for now. Like that, or maybe let's do like this, right? Yeah, let's do like this. Okay. So once again, I'm looking at it from the back. Now, so how I'll do the fillet here? Now, if I'll open up my fillet tool, by the way, this is the new version, so there's new options. Two of them are existing theoretical and build theoretical. Now, both of them are the coral fillets, but the description in the documentation for these new features is kind of vague. So I didn't really get enough an explanation except of these options are more accurate than original ARC in terms of math. So I actually tried different fillets with them and measured the coral distance. It's still, not kind of like spot on, like what you expect of the more superior feature, but it's better. To some extent it's better. So what I'm going to do is I'll click existing theoretical. Once again, it's a coral fillet. And for my coral length, I'll type 0.2. A form factor, I'll leave with 0.5. If yours is 1, change it to 0.5. Now what I'm going to do is I will click and build the fillet. Now I'll probably go to automatic just to illustrate what's going on here. Now, as you remember, we built these surfaces with great care and precision. They're very accurate. But when we look at the fillet, we will see that, well, first of all, there's two surfaces, right, already, which means that they're not spot on. And in fact, let me hide this stuff and use my radius tool again. Yeah, as you can see, it's wobbling around. And then it stops and it just starts to wobble again. Now this will not do, but this is not the only problem. Now, as you can see, as these two surfaces has different characteristics, they have a different character. The fillet is biased towards this side. Now, if you look from the profile view, you will see that endpoints of the fillet are not on the same line. Now, in theory, it's not a big deal, but for us, it's actually kind of not very beneficial. Now, to illustrate why, let me just duplicate this. Now, you don't really need to do it, actually, just to demonstrate. So, and then I will duplicate it again, flip it on the other side, and move it like this. So, as you know, we will be intersecting these rings a little bit later. So if I look closer here now, I will notice that these fillets are not matching here. That's because we are, at this point, we are connecting the outer shell with inner shell. And as the fillet is biased, right, here, we can't really match them. Now, in theory, this is not really that big of a deal. And actually, later in the model, we will encounter that once more, but that time we will actually add it like this. But for the top transition, I prefer to actually make them, in line. So what I'm going to do, let me just delete this stuff, go back here. So what I'm going to do is first of all, I need to figure out which edge I will use. Well, I'll probably use the outer edge, this one. So I'll create a curve, extend it using extend tool, extend it away like this. Now what I'm going to do is I will use the query edit for the history and undo it. Now I don't want this. I already have all what I want. Now what I'm going to do is I'll use project tool and project it on the y-axis here on these two surfaces. Click and project. Right. Now what I'm going to do, I will trim it. So I'm using a trimming tool and keep these surfaces. Now I will do some it may sound like a dumb thing to do, but actually it will work in our situation. What I'm going to do is I will build from the trimmed edge. Now, there is one of the golden rules for Alias, and not only for Alias, for most of the surfacing tools, which says that don't build from trimmed edges. Now, it's always a problem. And the reason for that is when you trim the edges, in most cases, you will get a really jagged edge. Now, it's kind of clean for you, but not really that clean for Alias. But in our situation, as we cut it straight horizontal and our surfaces is so accurate by default because they're under the rational flags and built the proper way, I actually can use them as an edges to build from. And actually, if I will measure the radius, once again, as you can see, this trimmed edge is perfect. See, it's perfect. So what I'm going to do next is I will use my blend tool, a freeform blend, freeform blend. And what I'm going to do is I'll click here, hit spacebar, and build as surface. Now, you may say, well, Alex, it's even worse than it was. Now we have even more segments, 1, 2, 3, 4, you know, these one and these one. Well, first of all, let me go back here, check it. So first of all, I will change my blend control shape to, I'll click lock. You know what, actually left it at 1.5. Actually, I like it. So I probably will owe you explanation about the blend controls. There is a shape and form factor, but I probably left it in the kind of like a quickie small video. For now, it's basically the characteristic for the parameterization of the curve. So how tight the acceleration will be here. It just moves these points tighter together, making a smaller space here. Now it's pretty good for me, and as you can see now it is on the same line. As you can see, that's perfect, but we have a problem because it's not perfect itself, because if I will, let me just measure it again. Yeah, it's wobbling, now what we're going to do in this situation, once again, I really want to have a really accurate transitional surface. So to do that, I will use duplicate curve, click on the edge and duplicate my curve from it. Now I will undo this, delete it. The only thing I really need is the profile. And then guess what? I will use the profile tool again. All right, click on that, accept, done. Click on the edge. It doesn't matter what kind of edge you pick. They're all really accurate, and build. And check this out. Now we have a really lightweight surfaces, which are perfectly matching. There is no additional spans, no additional surfaces. Of course, it's curvature. And on top of all of that, if I will measure the radius, yeah, it is spot on. So, okay, that's good. What am I gonna do next? Now, next I will just take it and flip it a couple of times like this, using my mirror command. And yeah, now I will do this stuff. I will select this portion, duplicate it, move it away, doesn't matter where, somewhere, and template it. Now I will use it later, I will need it later. As for these ones, I need to, yeah, what I'm gonna do is I will use another tool called the line. Now the line is from the key point curve toolbox as well. Once again, everything here has additional attributes. So I click and drag on a y-axis, select it, and change the length to 0.75, like this. Cool. Right, now what I'm going to do is I will select everything here, duplicate it, Ctrl-C, Ctrl-V, slide it away, use set pivot command and snap it on this side, and then snap it to my newly created line, like this. So now I define the proper position for the intersection. All right, so now what I need to do is I need to move all of this stuff back to the origin. Now to do that, well, I can group this, so Ctrl-G, and then center the pivot. Now at this point, please note that when I did that, it centered it in the center of mass. So if I will look from the side, now the pivot is here. Now it's in the center from the top, but here from the side you can see that it's in the wrong position. It's not in the bottom, which means that if I will move it and just snap it to the center, I will lose the position, because right now all of the model is basically laying down on the grid, and I would like to keep it this way for multiple reasons. So what I'm gonna do is I will, instead of just snapping, I will click on my gizmo on the axis, on the y-axis. So I click on it, and then I hold Alt and click in the the world origin, like this. So now if we look from the side, we are in the center, but it's still laying down on the y-x plane. So basically what I did is I constrained the movement only on the y-axis. And once again, it's really easy to do with the gizmos. That's why I always encourage you to work with the gizmos and hook it up to your hotkeys. All right, so these are out of the way. Let me just delete this, and let me delete this, like this. And actually, let me delete this as well. I don't need that. All right. So remember that I still have this piece here, and I will need it later. But for now, I left only with this piece because I would like to build these transitions first. As you can see, there is a lot of intersections, you know, here and here and here and here. Now, I would like to solve all of this stuff. And actually, it looks like I really didn't even align it. Let me just kind of center it again. Wait a second. Oh yeah, okay, sorry. So I didn't really, so let me ungroup this stuff, group that again, center the pivots. Now I'm not working with the, these one, I'm working with the global, and just snap it again. All right. Yeah, I'm sorry, I talked so much how awesome it is, and I just misclicked and kind of placed it a little bit off. So now I used the center mass and basically, sorry, the global center, and just aligned it like this. Yeah, okay, now it works. So yeah, I wanna work with these ones, and yeah, probably I will do it in the next video, because we are, how much we're recording already? Let me check. Oh, it's like 35 minutes. So yeah, okay guys, that's it for this lesson. In the next we'll proceed with this model and do some filleting work around this part. Yeah, until then,